Question 21. Enlarge triangle ABC by scale factor -2, center 4, 1. So they've shown us where the center is, 4, 1. There's the triangle. And it says scale factor -2. Now the negative means it's going to be the other side of the center of enlargement, and it's going to be flipped over. The 2 means it's going to be twice as big. So BC, for example, is going to be, instead of 1 square wide, it's going to be 2 squares wide. What we're going to do is draw these lines through here, through the center of enlargement from each corner. And if you look at point B, it's 2 down, 2 across. So through the center of enlargement, we're going to go 4 across and 4 up. So actually, I think my line wasn't drawn carefully enough. I think it should be probably there. If you look at C, that's 2 down, 3 across. So we're going to go 4 up, 6 across, which will get us to there. So again, my line is not terribly well drawn. And this is quite tricky when you're trying to go through the center of enlargement with the lines. You've got to be a bit more fussy than I was then. And A was 4 across, so it's going to be 8 in the opposite direction, which takes it to there. But now let's join those 3 points and see how it's looking. And it is 2 wide. It is the same shape, but flipped, and twice as big. And we really should label the points of the new triangle. That's matching to A, so that's called A dashed. Going from B to there, that's going to be B dashed. And C is to there, so that is C dashed. Question 22, we have to identify which of these represents the shaded region. Circle your answer. So we've got that one there. That's A with the intersection of B dash. That means everything that's outside B. B dashed is everything outside B. So there's B dashed. That's everything outside B. So B is that circle there. Everything outside of that is B dashed. A union of B dashed, that is actually the one that we want, because it's everything that's in A united with, I always think of union as united with, joined with everything that's outside of B. So it includes that area there. So it is that one there. Question 23. A shopkeeper compares the income from sales of a laptop in March and April. So the price is 1/5 more than March in April, and the number sold is 1/4 less than March. By what fraction does the income from these sales decrease in April? So we know the income's gone down. By what fraction has it gone down? Now, I'm going to pick on a price in March. So let's say the price in March was £100. Quite cheap for a laptop, but let's say that. And the number sold in March, well, let's say it was 4. So in March, 4 lots of 100, the sales value, £400. Now, the price in April is 1/5 more than March. 1/5 of 100 is 20. So in April, the price is 120. It's gone up by £20. But the number sold in April is 1/4 less than March. So 1/4 of 4 is obviously 1. The number of sales must be 3. The sales value would be 3 lots of 120, which is, of course, £360. The decrease is £40, and we have to compare that to 400. So 40 out of 400, the sales value in March was 400. The decrease is £40. So 40 out of 400, obviously we can just cancel out those zeros. So it's 4 over 40, which is 1 over 10. So the fraction, by what fraction does the income from these sales decrease in April? It's gone down by 1/10. Question 24a, work out the value of 2 to the power 14 divided by 2 to the power 9 squared. And that bit is squared and it's inside brackets, as you can see. Give your answer as a fraction in its simplest form. So we have to deal with the brackets and that index first. Now 2 to the 9 squared is 2 to the 18, because it's 2 to the 9 times 2 to the 9, which is 2 to the 18. So we've got 2 to the 14 over 2 to the 18. So you will remember as well, I'm sure, that if you're dividing indices, then you are going to subtract. So we've got 2 to the -4 give your answer as a fraction in its simplest form. So that's 1 over 2 to the 4, but 2 to the 4 is, of course, 16. So the answer is 1/16. Question 24b, work out the value of 25 to the power 3 over 2. Now the easy thing here is always to look at the number at the bottom. 25 to the power of 1/2 simply means the square root of 25, which of course is 5. And then you cube it. So the 2 at the bottom is showing us that we find the square root, and then we have to cube it. 5 cubed is, of course, 5 times 5 times 5, which is 125. Question 25. Here is a sketch of the graph of y equals cos x for values of x from 0 to 360. So let's have a look at the graph. 0, 360, there's x, obviously there's y, and you can see 0 degrees, 90 degrees. Have a good look at those. You know already probably that cos of 0 is 1 and cos of 90 is 0. And look, if that's 90 and that's 0, that must be 30 there and 60 there. And you will remember, I'm sure, from the 30, 60, 90 triangle, 30, 60, 90, that is 1, 2, root 3, and cos 60 will be equal to adjacent over hypotenuse, which is, of course, a half. Cos 60 is a half, and we can find that from the 30, 60, 90, 1, 2, root 3 triangle. But we can also see it, look, on the graph. If we look at cos 60 and go up to the graph, you can see that it arrives at a half. Well, that's good news because that's what we expected. Let's go across from there. And the interesting thing is that cos 60 is worth a half, but so is cos of wherever that is. Now remember, every interval here is 30 degrees, so 270 plus 30, that must be 300 degrees. So we know that cos 60 is a half, but cos of 300 is also a half. It shows it on the graph. So part B of question 25 says that cos x is negative cos 60. Well, we know that cos 60 is a half, so negative a half is going to be there. Let's draw a line across the graph at that point, and you can see that there are two values that are going to satisfy this. But they've said work out the value of x when it's between 180 and 360. So between there and there, the only place is there. And going up to the graph, we can see we're taking 30 off 270. So that's 240 degrees. Question 26. B is 2/3 of C. And then they've given us 5a equals 4c. Work out the ratio a to b to c. And give your answer in its simplest form where a, b, and c are integers, so whole numbers. So let's see what they've given us. B is 2/3 of c. 5a is equal to 4c. Well, I'm going to take the 5a equals 4c, and I'm simply going to divide both sides by 5. So we've got a equals 4c over 5. Now I'm going to put these in a row, a to b to c, so I'm going to write 4c over 5 to b, 2/3 of c to c, which is c itself. Now I'm going to multiply every element by 5 to get rid of that 5 down there. So if we do that, they all stay in the same ratio, but it's just getting rid of that 5. So multiply each bit by 5, that's going to be 4c, that's going to be 10/3 c, and that's going to be 5c. I want to get rid of the 3, so I'm going to multiply every element by 3. 12c to 10c to 15c. Now if we remove the c's, because they've all got c's, you can see that the ratio is 12 to 10 to 15. And if you check back, b is 2/3 of c. Well, this one was b. 10 is 2/3 of 15. 5a makes 4c, 5 12s are 60, 4 15s are 60. So it works very nicely. 12 to 10 to 15. Question 27a. Joe wants to work out the solutions of x squared plus 3x minus 5 equals 0. She says the solutions cannot be worked out because that does not factorize to that, where a and b are integers. Is Joe correct? Tick a box. Well, she's correct that it won't factorise, but I don't think she's correct that we can't find any solutions, because I'm sure you'll remember the quadratic formula. Let's see if the quadratic formula is going to work for us. With the quadratic formula, we're going to have x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, this formula will always work if that bit is a positive number. If that's negative, it can't work because you can't square root a negative. But if that's a positive number, it'll work. So let's just test that out. We need to see if b squared minus 4ac is positive. b is 3, so 3 squared is 9, minus 4 times a, which is 1, times minus 5. So minus 4 times 1 times minus 5 is going to be plus 20. So we get 29. It is clear that that is positive. So no, she's not correct. We can use the quadratic formula. Question 27b, without expanding any brackets, show how to work out the exact solutions of that and give the solutions. Without expanding any brackets, I always feel it's quite good to avoid expanding brackets if you can. We've got to find the exact solutions of that. So here it is, 9 times x plus 3 squared equals 4. Now if we divide both sides by 9, we're going to have x plus 3 squared equals 4 over 9. And you may notice that both of those are square numbers, so we can square root this and say x plus 3 is the square root of 4 over 9. But the vital thing to remember is when you square root something, it can be plus or minus. It can be positive or negative. For example, we could say the square root of 4 is 2 or minus 2. And so that's what we've got to remember here. So let's do this square rooting. So x plus 3 is equal to plus or minus 2 over 3. So x will be equal to plus 2 over 3 minus 3. I've taken 3 off both sides, and that will give us negative 2 and 1/3. 3 subtract 2/3 is 2 1/3, and it's a negative, of course. Or minus 2/3 minus 3, which will be minus 3 2/3. Those are the two solutions to that little equation there. Question 28. Simplify root 80 plus the square root of 2 2/9. And give your answer in the form a root 5 over b, where a and b are integers. Let's do root 80 first. I'm going to put that over this side. And to me, 4/20 is the easiest way to split 80. So we've got that root of 4 times 20. But you might notice that 20 is 4 times 5. So I'm going to write the square root of 4 times 4 times 5, which is the square root of 4 times the square root of 4 times the square root of 5. So all I've done is split that into 3 different square roots that all multiply together to make 80. Now the square root of 4 is 2. Square root of 4 is 2. And look, we've got a root 5. That's good news because we're looking for that. So actually what we've got here is 4 root 5. But we've only done part of it. We've done that part. So now I'm going to do the square root of 2 2/9. Well, I'm going to make that mixed number into an improper fraction. So we've got the square root, 2 9s are 18, add 2 makes 20 over 9. Now the good news here is that we've got a root 20 there, which we've seen before is 4 times 5. So we can write this out as root 4 times 5 at the top over root 9 at the bottom. Now that's root 4 times root 5 all over root 9, which of course is 3. So let's put that 3 in. Root 4 is 2, so we've got 2 root 5 over 3. So that's that one expressed like that. And we've simply got to add these together. So we've got 4 root 5 plus 2 root 5 over 3. So this one's a fraction. That isn't a fraction, so we're going to make it into a fraction with a denominator of 3. So we're going to times this one by 3 over 3. 3 over 3 times 4 root 5 will give us 12 root 5 over 3. That's this one. Pulling this one all the way down to there, we've got 2 root 5 over 3. We're adding those together. So we're going to have 14 root 5 over 3. 12 over 2 is 14. 3 is the denominator. 14 root 5 over 3. Look, A is 14, B is 3. So we better put the answer where it belongs. We're going to have 14 root 5 over 3, and it's in the form that they asked for. Question 29. Here are our sketches of two graphs. There's graph A, and there is another one, y equals x squared minus 1. So that's the equation for this graph here. The graph of y equals x squared minus 1 is translated 3 units to the left. So this graph has gone 3 units that way to give us graph A. Okay. The equation of graph A can be written in the form y equals x squared plus bx plus c, and we've got to work out the values of b and c. Remember from your work on functions, if we've got a function of x, and in this case, function of x equals x squared minus 1, if it's translated 3 units to the left, then 3 is actually being added to x. So we've actually got to do the function of x plus 3. And that means wherever x appears, instead of x, we write x plus 3. So here's our equation, y equals x squared minus 1, but we're going to write instead y equals x plus 3 squared minus 1. Let's multiply out that bracket. So we've got x plus 3 times x plus 3, and don't forget the minus 1 there. So x times x is x squared plus 3x plus 3x plus 9 minus 1, and that's going to give us x squared plus 6x plus 8. 3x plus 3x is 6x plus 8. So there, bx plus c, so b is worth 6 and c is worth 8. Question 29, part B. The graph of y equals x squared minus 1 is reflected in the x-axis to give graph B. Work out the equation of graph B. Let's look at the graph again for a moment. There it is, y equals x squared minus 1. That's the graph we were looking at just now. And it's reflected in the x-axis, which means it's going to be looking like that. That's just a sketch, of course, but it's just flipped over. Remembering your work from functions, if we've got f of x, there's the function of x. If it's reflected in the x-axis, then we've got negative f of x. Simple as that. So you've got f of x reflected in the x-axis, you've got negative f of x. So we've got y equals x squared minus 1. If we reflect it in the x-axis, we're going to have y equals minus all of that. So that would be y equals minus x squared. Minus times a minus is a plus, so plus 1. But it's tidier to write it out like this. Y equals 1 minus x squared. Just putting the positive at the front there. And question 30. Show that the value of cos 30 times tan 60 plus sine 30 is an integer. In other words, that somehow ends up as a whole number. Let's see how it's done. Well, let's use that 30, 60, 90 triangle again. 30, 60, 90. And that is the 1, 2, root 3 triangle, of course. Cos 30 is going to be adjacent over hypotenuse, so that's root 3 over 2. Tan 60, there's the 60, so now that's the opposite. So that's root 3 over 1. And sine 30, let's find that at the same time. Sine 30 is opposite over hypotenuse, so that's a half. Now the first thing we have to do is to multiply those two together. So cos 30, that's root 3 over 2 times tan 60, which is root 3 over 1. And you know that root 3 times root 3 gives you 3, and 2 times 1 gives you 2. So that part is 3 over 2. So we've got the 3 over 2, and sine 30 is a half, so let's add that. So now we've got 4 over 2. And of course, 4 over 2 is worth 2, which is an integer.